Hey guys, welcome to this week's AECVC. So I'm going to talk about a topic that was perhaps the origin topic of construction technology in the minds of many investors, and that is 3D concrete printing. And I'm going to talk to you about it, not because I have answers, but because I have questions. So tune in, and perhaps at the end of this video, you are one of the ones that can educate me on why 3D concrete printing specifically for residential use cases should be around. Hey guys, so this week I want to talk to you about one of the most funded and longest standing subsectors of construction technology, namely 3D concrete printing. But I don't want to talk to you about it because I have a thesis for it. In fact, I want to talk to you about it because I do not have a thesis for it and I don't get it. So perhaps someone can actually help me understand this, because there's so many experts out there that I would love to hear from, why they think that 3D concrete printing for specifically single family homes or even small multifamily dwellings should be the standard solution going forward. So please help me understand this. Let's start with speaking plainly. So when you think about the single family homes, and specifically my question there with regard to 3D concrete printing, I just want to speak plainly to everyone here. This is what a single family home looks like. This could be a US based home. This could be a European home with some style adjustments. This is a home that you will find all over the world. And so this kind of home can be built basically stick built. That's the go-to way of building in the US a single family home, or even like a small multi-story multifamily home. Stick built. What you see here is that we're not filling the walls with material. We're making sure that the low structural integrity, but some structural integrity, is achieved by sticks built out of timber. Now, another way could be a modular way of building the same type of home that you see here. It could be, this is a popular way of building in Germany, for example, with these kinds of very large, let's call it cinder blocks, type stones, and you put some mortar in between. That's another way of doing it. And now 3D concrete printing a single family home would look exactly like this. That is the go-to norm. And for this kind of technology, a lot of funding has been allocated to a bunch of different companies over the last 10 to 12 years. And there's one company that actually has concentrated a ton of capital for this. And they are very largely in the residential space. Now, to me, it's baffling, and I don't understand it, because when you think about when concrete is being used, you have to think that in the end, it's two defining factors. The first factor is it's large surface areas. And the second one is you need high structural integrity, because then I can combine it also with steel reinforcement. And so when I have large surface areas and or I have high structural requirements, that's when concrete shines. Think as a most extreme example of tunnels. Think of highways, think of bridges, right? Think of high-rise buildings. That's when concrete shines, oftentimes in reinforcement with rebar. And so I cannot think historically of a high volume application for concrete that has neither of the two. That is basically small surface areas and low structural integrity requirements. But that's actually residential for the most part, except in high-rise. Now, that means that when you think of concrete, and let's say you even go into these kinds of applications, you're still going to compete with the incumbent method. And that, for the most part of the world, is ready-mix concrete. The concrete that gets mixed in a concrete plant from different silos, gets mixed on site, put into a mixer truck, and the mixer truck has more or less 60 minutes to deliver it to the site, and they pour it out of the truck there, and they'll make sure that it gets into the right formwork. But that is a highly efficient process, actually, because you're using gravity to place the concrete in its place. Now, it is labor intensive because it's not easy to actually move the concrete once it begins to set, but isn't fully set yet. But against that method, whenever I could actually use ready-mix concrete in, again, large surface areas, the 3D concrete printing method, in my mind, would never win, actually. So what is then the actual reason for 3D concrete printing to actually win against any of these established methods? In my mind, I wonder, is it then the automation that people think will propel 3D concrete printing as the main building method for residential building with low volume application, low surface area application, and low structural application? Maybe. So what is true is that it takes about 50 to 100 man days to build a 1,500 square foot single family home. And so this is man or woman days that I can eliminate by automating it with an on-site gantry printer or an on-site arm type printer, of course. And I can also gain additional control. The problem with that is none of that in my mind would actually be more competitive or superior to an on-site robot that, for example, does placement of the sticks in place. I have seen such example that puts bricks in a brick wall type single family home construction. These solutions also exist, or even in stick framing or automating modular offsite, which I'm not a particularly fan of modular offsite with timber, but there are reasons why that actually is a category. And so none of these to me give me examples where 3D concrete printing on site for single family home or small multifamily home applications would be superior. Finally, there's a sustainability aspect here, right? So if you compare it to ready-mix concrete, you will typically, unless you have a magical method, require 20 to 50% more cement in order to achieve the viscosity that you require for 3D concrete printing. Now, there are optimizations that are being found by these players, both incumbents as well as startups. And I know that the amount of cement that we need, they call it in the end, the ink is the recipe, and the printer head, there's innovation there. I know that we're finding more innovations, but who actually believes that with 3D concrete printing, you can achieve a lower cement content than in the incumbent method with ready-mix? I haven't met such a person. And that means that when for ready-mix concrete, for such an application, you perhaps need 350 kilograms. With 3D concrete printed concrete, you would perhaps need 400. And so that is a substantial difference, even in the best case, which goes straight into the environment, because cement is the material that ultimately, when it gets produced, does emit the embodied carbon. And so for me, I can't find an angle in good faith, actually, where 3D concrete printing for residential use cases, the way it's actually being applied today by the incumbents as well as the startups that get funding for it, actually has a superiority. So I'm genuinely reaching out to the community here to educate me, like, why does it make sense to use 3D concrete printing for residential use cases? Thanks a bunch, guys. Hey guys, thanks for tuning in. Make sure that you subscribe under acvc.com, and you can also find me on LinkedIn. See you next time.